Welcome everybody to this SUSECon 2025 talk. This talk is about CIS benchmark compliance with RKE2 and SUSE NeuVector. My name is Daniel Drack. I'm a senior DevOps engineer at FullStacks. We are a SUSE partner. I'm also a community organizer and the founder of Cloud Native Austria. If you want to reach out to me, just drop me a message. My internet handle is Thractor, or just send me an email at daniel.drack@fullstacks.au. Now, this talk is about how to achieve compliance with RKE2 and SUSE NeuVector, or SUSE Security. For this, we're going to talk about what RKE2 actually is in a nutshell. We're going to talk about what SUSE Security is in a nutshell. We're going to talk a little bit about what CIS benchmarks actually are. And then we're going to have a deeper look in how to evaluate for compliance, how to fix compliance findings, and how to include them in your day 2 operations. I'll conclude the talk with some lessons learned and some further reading. Now let's start off with what RKE2 and SUSE Security actually is in a nutshell. Let's start off with RKE2. Well, RKE2, also known as RKE Government, is Rancher's next generation Kubernetes distribution. It's a fully conformant Kubernetes distribution that focuses on security and compliance and is especially built for the US federal government sector. RKE2 starts with launching its control plane components as static pods, as other Kubernetes distributions do as well, managed by a kubelet. And the managing process behind that, the RKE2 server or agent, is embedded as a systemd service, and it ships with containerd as its default container runtime. The primary way to configure RKE2 is simply by using a YAML file, which is very, very convenient. There is also a possibility to provide command line arguments, for example, or also environment variables. But the primary way to configure your RKE2 installation is by configuring it via a configuration YAML file, which is actually very convenient and quite straightforward. So RKE2 is SUSE's state-of-the-art bulletproof Kubernetes distribution configurable via YAML file. This is pretty much how the architecture of RKE2 looks like. Imagine you're having multiple nodes, as you usually do in a Kubernetes cluster. You're having control plane nodes and worker nodes adapted to RKE2 notation. This is what you can see on the left-hand side, which is called an RKE2 server node, which represents the control planes of a typical Kubernetes cluster. And you can see that as well for the server, also as for the agent nodes, which represent the worker nodes, you see that there is an RKE supervisor process in that case, which is actually the RKE2 binary. This binary then manages the kubelet, is responsible for installing everything that's necessary to start and run the Kubernetes cluster. And this will pretty much prepare on the left-hand side the static pod manifests for all the control plane components, API server, etcd and such, which will then be started as static pods by the kubelet. RKE takes also care of providing container runtime, also several CLI tools. And on the right-hand side, you can see it works pretty much the same for the worker node side. So also here, RKE2, the binary, manages the container runtime, manages kubelet, deploys some useful and neat tools on top of Kubernetes in that case. For example, kubeproxy, a Helm controller to handle Helm charts, metric server, ingress, core DNS, etc. And last but not least, you can then deploy your user-defined workloads once the cluster is up and running. So this is how RKE2 pretty much works in a nutshell. Install a single binary, configure it via a configuration YAML file, and then join the different control and worker nodes. Now, what's SUSE Security? First and foremost, SUSE Security is formerly called NeuVector, so you've probably heard that name before. So NeuVector is actually an end-to-end container security platform. This includes end-to-end vulnerability scanning and runtime protection, which is actually amazing. NeuVector or SUSE Security also comes out of the box With an admission controller implementation, it provides web application firewall and data loss prevention, filters all capabilities. It comes out of the box with a threat detection functionality that is actually configured and run automatically in the background. It also provides some kind of compliance and auditing capabilities. It has a great API, so even the UI is configuring all of NeuVector via the API. So everything you can click, you can also do via the API. NeuVector comes with rich container scanning capabilities, and as already mentioned, runtime security on file, process, and network layer. From an architectural point of view, this looks something like this. On the top right-hand side, we have the manager component, which is actually just the UI component, talking with the controller, which is the backend, usually a deployment of 3 pods via the REST API. On the top left-hand side, we have additional integration services that can be used but are not necessary for the core functionality. And on the bottom, we have the enforcer pods, which is a daemon set which is running on each node of the cluster, actually enforcing the policies that we specify. And in addition to that, we have a loosely coupled scanner pod, which is responsible for scanning container images. Now, let's have a short look at what SIS benchmarks actually are, just in a nutshell, to get an idea of what we're actually talking about when we talk about to achieve compliance regards them. Now, the SIS benchmarks are actually a prescriptive configuration recommendation for more than 25 vendor product families. They represent a consensus-based effort of cybersecurity experts all around the globe that should help you to protect your systems against threats. So we're actually talking about curated configuration best practices for certain tools, operating system, products, if you will. So a variety of products actually. The Kubernetes benchmark in particular provides a prescriptive guidance for establishing a secure configuration derived from best practices from the Kubernetes security expert ecosystem. And it's always, each Kubernetes SIS benchmark version is always valid for at least one or multiple Kubernetes versions. SIS benchmarks are commonly distributed free of charge in PDF format. And if you're also a SIS Secure Suite member, you can also download them in more machine-readable formats such as Word, Excel, or XML, for example, if you need a more editable or machine-readable version of them, which is actually quite neat sometimes. One thing to conclude here is that SIS benchmarks sometimes or usually implement 2 levels, if you will. Level 1 being some kind of a base recommendation, and level 2 being controls for defense in-depth configuration. The SIS Kubernetes benchmark only implements level 1. So in comparison, for example, most Linux SIS benchmarks provide level 1 and level 2 guidance recommendations. The Kubernetes benchmark only provides level 1 recommendations. All right, let's have a brief look at one of these SIS Kubernetes benchmarks. In that case, it's the most recent one, since that's the one we're also going to have a look at in greater detail, which is 1.9.0, which is valid for Kubernetes versions 1.27 to 1.29. And as of the date of this recording, you already might see that this is kind of outdated because we're now already above Kubernetes 1.30. In a nutshell, on the left-hand side, you see the folder structure of such a SIS benchmark. Usually they are grouped together in domains and subdomains. In that case, for example, it's split into the domain of etcd, the control plane configurations, worker node configurations, and an arbitrary set of policies, which underneath are split into subdomains focused on the parent domain. So for example, we have authentication, authorization, and logging for the control plane. And in these folders, we can then find a sum total of 123 controls, which at the end of the day are technical recommendations on on a very low level usually. So the must and must nots of how to use certain configuration parameters, how to set certain file permissions, etc. So usually most of them are quite deep technical, if you will. Exactly. Now, we do have actually two problems when it comes to CIS benchmarks. The first is, if you want to state that your system is CIS benchmark compliant, you actually need to specify which layer of your system, or in case, all of them. So the first problem we actually see is that, for example, an application, and like in this case, a containerized Tomcat application running in a Kubernetes cluster on the Linux node, consists of these four logical or technical layers. On the bottom layer, we have, of course, the operating system. Then we have the Kubernetes layer, the image or Docker layer, and on top we have the application layer. And all of these layers might or might not have, but in that case, they definitely do have a recommended CIS benchmark specifically aimed at this layer and the product behind it. So for example, we have a CIS SUSE Linux Enterprise 15 benchmark for the operating system. We have, of course, our Kubernetes benchmark for Kubernetes. We have a Docker benchmark, which also contains a section about Docker images. And there is also a CIS benchmark for Apache Tomcat in that case. Now, if you state that your ecosystem or your platform is CIS benchmark compliant, you actually need to make sure to either specify the layer, or you need to make sure that all the layers are compliant. And the second thing is that if we talk about benchmark compliance of certain products or tools, if you will have the problem, for example, if we consider Kubernetes, that the same outcome is achieved by different implementations, distributions, if you will, distros. So for example, if we have a look at the vanilla or kubeadm folder that contains the static pod manifests, this is etc Kubernetes manifests, and there are CIS benchmark recommendations about the file permissions that need to be set for the YAML files in this folder. Now, if you have a look at RKE2, RKE2 makes use of the same technical system and the same idea of having static pod manifests, but the folder is different, which at the end of the day means if we want to check for compliance in an automated way, we need to have a way to actually customize the rule set or the policy that is checking the file permissions, for example, of these YAML files for different distributions. And this is especially true for our use case if we want to achieve CIS Kubernetes benchmark compliance for RKE2, since the normal Kubernetes benchmark is focused on kubeadm or upstream vanilla Kubernetes. All right. Now, the topic is, how do we actually evaluate the compliance according to the CIS benchmark and or its other layers for our setup? Now, the first question we need to answer here is, why do we actually want to evaluate it? Is it for an internal purpose to improve security, which should always be the case, or is it also for the external purpose of proving compliance to an external auditor? So do we actually need to report our compliance state, which is in some terms a different use case? Now, to demonstrate this case here, I created a test RKE2 setup with our lab rancher, which is of the most recent version. Also installed SUSE Vector or SUSE Security in the most recent version, and I deployed some dummy workload just to make it more realistic. Now, the question comes, how can we actually evaluate compliance? Well, out of the box, RKE2 obviously has no tool to do that, since RKE2 is a Kubernetes distribution and not a compliance validation or scanning tool. So there's no out-of-the-box solution with RKE2. And I'm sorry to say, also the capabilities of NeVector are somewhat imperfect, let's put it that way. Now, what I mean by that is that SUSE Security provides extensive capabilities to check for compliance, but the applied compliance framework, so for example, the CIS Kubernetes benchmark, is not configurable. So we are definitely locked in that case with the Kubernetes benchmark 1.8.0. Doesn't matter which Kubernetes version you actually want to scan. And there is also a second case for policies in place. In this case that we can see, we have compliance checks with a category marker of Docker or image. Now, if you can recall what I said before, there is no image CIS benchmark. There is only a Docker CIS benchmark, and there we have a certain section that is concerned with the build process and with the Docker files and the images. So it's not perfectly clear which CIS benchmark or compliance frameworks is actually used to evaluate the state of the containers and of the nodes. The cool thing about NeoVector is you can check the compliance of Kubernetes pretty much with one click and pretty much out of the box. There is also a mapping available from CIS to other usually or well-known compliance frameworks, for example, GDPR, HIPAA, and PCI DSS, which is very cool because you can select, for example, that your application might have to be compliant with PCI DSS. Then you just need to check this box and you get the recommendation of which CIS IDs or with CIS checks you need to be compliant with or you need to fulfill. The downside here is that there is no documentation available of how this mapping works. So this might not be the ideal solution to actually report this finding to an external auditor because this information is missing. Okay, to sum up, we only have one pinned version of CIS scanning available here, so 1.8.0, which might be suboptimal. We don't know which version of framework is used for these Docker and image scans. They might still be valid, so it's definitely a good source for inspiration and for feedback, but it might not be the perfect place to create reliable compliance report for externals. And we cannot check the compliance against certain Linux CIS benchmarks on the node operating system. So this is purely focused on Kubernetes. The framework mapping to other frameworks like HIPAA or PCI is actually very cool, but unfortunately the mapping information is not available as of yet of which CIS ID is mapped to which framework ID in those other compliance frameworks. So again, the question is, how can we actually evaluate compliance? Well, certainly not with RKE2 and maybe also not with NeoVector. So here to the rescue comes the Rancher CIS benchmarking tool. This is actually a tool that is built on top of Kubebench, an open source tool, where SUSE provides the policies specifically tailor-made for their Kubernetes distributions, namely K3s, RKE2, and RKE1, which is amazing because you can now scan against CIS compliance with a very specific policy set, and you're also able to customize and create your own policy checks, which is really, really amazing because you can adapt the policies. For our use case, what I did is I created this fresh RKE2 cluster. I installed this tool, which is available via Helm chart or via the Rancher application catalog. So pretty much 2-click install, works great. And I ran a check. And what we found is that we run a total of 130 checks, which is pretty much what we saw the amount in the Kubernetes CIS benchmark. And we have some findings here. Now, before we talk about the findings, there's one thing I want to clarify here as well. This is also only checking the Kubernetes controls. And if we actually want to check the node operating system, for example, SLES as well, SUSE also recommends to use a tool called OpenSCAP, which is an implementation of the SCAP protocol or SCAP standard, which is backed by the NIST. At the end of the day, this is pretty much a policy standard written in XML and fed to a command line tool, which is then able to execute the checks provided via this XML. There's a whole tool landscape around that. And again, SUSE is also recommending to use OpenSCAP if you want to harden and scan your Linux operating systems. Now, back to the findings. The status quo is that as of this check, we can see that we have 130 total checks, out of which 80 were passed. We had 42 warnings and 3 fails. We're using Kubernetes version 1.30 with the most recent sys profile of 1.9. So this is not the perfectly applicable sys profile, but since it's the latest one and we have nothing better, it's good to go. Again, we're using an RKE2 cluster running on top of a Ubuntu 22. And we only have 3 fails and 42 warnings, which is actually pretty neat for a fresh RKE2 setup. So spoiler here, RKE2 is actually very secure out of the box. Now, let's have a look at the detailed results. 40 of these 42 warnings that we found actually have this suffix called manual, which indicates that this is not a warning per se, but this just needs you as an administrator to manually check if this control is already fulfilled or not. For most of them, if you go through them, and we'll have a look at that in detail, they are being able to be fixed in the RKE2 config. There might be some controls depending on which RKE2 version you're using, because they're making improvements version by version that you might need to fix afterwards with some kind of configuration as code tool, for example, to fix file permissions and such. For some findings, the only reasonable way of dealing with them is simply to accept the finding, because you can change them or because they don't affect you. So you can just accept the risk, if you will. This might be controls, for example, like this minimizing access to secrets. Well, minimize is a subjective term. You can't restrict access to secrets. So you need to make sure to, of course, minimize it, but this is nothing you can't check that automatically. So therefore, you just pretty much need to accept this control. Or, for example, to only mount service account tokens where necessary. Well, also necessary is kind of a subjective term. Need to be evaluated case by case. So in that case, you might just have to accept the finding and probably find a process on how to make sure that only the minimum amount of service account tokens are actually used and not auto-mounted. All right. Some controls that need to be fixing can also be fixed or implemented. I think that's the better phrase, with SUSE Security, SUSE New Vector. We're going to talk about that also in a second. So, for example, all the admission control recommendations, for example, minimizing the admission of root containers, also ensuring that your cluster has a policy engine available, which in that case would be SUSE Security. Or, for example, also to ensure that certain namespaces must or must not be used, which can also be handled perfectly by SUSE Security. We had 3 fails. All of them could be identified, and they were misconfigurations, if you will, by the previously deployed dummy applications. So these were actually valid findings that could be dismissed out of the box. Most of them were because they were actually deployed in a default namespace. So there's no big finding here, but still valid. So this was a good insight. Now, if it's actually about fixing these issues, we have one great guide at our hand, which is called the RKE2 hardening guide, which is provided as part of the RKE2 documentation, which will actually help you to fix or implement each and every finding that this benchmark tool provided you. So, for example, here we have the finding that is a warning. This is a benchmark ID 1.2.3, which says ensure that the deny service external IPs is set manual. So it means you need to validate if this is the case manually. The hardening guide explains that the remediation for this is to add an additional Kube API server argument in the RKE2 configuration file, and it gives us a detailed explanation of where the file is to be found and which arguments need to be set. There are also some further reading sections, etc. So this is a very detailed and straight to the point documentation and implementation guide of how to get rid of most of the findings. Now, what we can see here, for example, is is one of the cases that I mentioned before, minimizing access to security or access to create pods, because this is something this can't be prohibited in a technical way. The remediation is to just remove the get list and watch access rights for secrets in the cluster, which is true, but this is nothing you can do automatically. So you pretty much need to accept these risks as they are, because there's not much and definitely nothing technical or automated that you can do about that. So note that. And the last category of findings, which is actually quite a lot of those 40, is regarding everything that has to do with admission control, policies, policy engine, security contexts, namespacing, etc., which are all the controls that can actually be implemented by using admission control, for example, admission control policies provided by SUSE Security. So in that case, you need to make sure, for example, that at least one active policy control mechanism is in place. Well, yes, policy engine is SUSE Security, so that's the case. We need to minimize the admission of privileged containers. As the name already said, this can be implemented by an admission controller, so check mark there as well. We need to ensure that the CNI that supports network policies is in place. Well, also though SUSE Security is not a CNI, it can implement network policies or runtime security to a great extent, which is the same capability as network policies bring to the table. So I'd suggest that this is the same functionality. So we also implement that case with SUSE Security. We can definitely ensure that some kind of secure computing profile is set, as other security context configurations as well. And we can also make sure that certain namespaces must or must not be used. Now, by using SUSE Security with an admission control, best case with an already established baseline catalog of controls, rigorous image scanning, and making use of the full capabilities of runtime security and network policies, if you will, you can definitely implement most, if not all, of the warnings and findings that were still left that couldn't be fixed in the RKE2 config. So, having said that, how about day 2 operations? When it comes to day 2, the first thing you might actually want to do is, for all the findings that you identified with a certain profile and a certain scan, you might want to exclude the findings or the IDs which you actually were able to fix in the configuration, the manual ones, or that are now implemented by using SUSE Security, so that if you run your next check, you're not always getting warnings, but they're actually just skipped, and you're getting a green test result. Because if something changes and you run the same check again and something is really going south, then you can actually see a valid warning or a valid failure, and not one that is just ignored or excluded by preference. So update your profile, which you can do perfectly fine in the UI of Ranger, for example, and exclude all fixed or accepted IDs. The second thing you might want to have to do is to document how and why these checks were excluded. So for example, at FullStacks, we're doing this with the documentation as code approach. We have the documentation close to the newly created or adapted policy, so that we always find the matching document. But you can actually see that for all the IDs that we accepted or that we fixed or that we took certain measures for, we create a short piece of documentation that describes how and where we fixed that. So for example, in that case, we adapted the Kube API server arguments, as we did in the previous example, and we added the anonymous authentication equals to false parameter there. Now, here comes the sad part. When it comes to day 2, the thing you need to do is you need to continually scan your environments, which can be automated, but then you actually need to review and adapt your policies, probably with every update, depending on the changes. Update the documentations for each version to have a very transparent history, And yes, it's definitely as tedious as it sounds, but it's the best we have at this point to come up with a very transparent and still usable compliance statement that is also valid for an external auditor. All right. So the lessons learned for us were that compliance usually has two goals. The first thing is to improve security for your internal organization. And the second is to being able to provide a report for external audits. Compliance checking across multiple stacked layers or stacked layers is particularly hard. And this is due to the lack of available and good and user-friendly tools that are able to check systems on each and every layer, so from the operating system to the application, and that also provide the policies. Since writing policies is a tedious amount of work, there are lots of checks to being implemented, to being maintained. So this is actually a tooling problem. NuVector is definitely a fine recommendation, but in our point of view, it's not well enough documented to also being used for external reports, if you will. So it's definitely good for indications. It's a great tool for everything related to security, but for scanning compliance and generating reliable and bulletproof reports, it's probably not the best tool. Checks, just as a general statement, they cannot be fully automated yet. This depends either on the check, because it's just not something that's technically that graspable that you can write a check for that, or because the technology just isn't as far as necessary to actually check such a thing. RKE2 is definitely good, close to great. It's not perfect by default, but as we've seen over the last 2 years, the standard of compliance is getting better and better by the release. So as of now, it's definitely the best Kubernetes distribution we know so far, especially for on-prem installations. And it's definitely going in the very, very right direction of being 100% compliant out of the box. Not yet, but I think they're definitely on the way there. All right. And I think the concluding note here is that compliance documentation is a lot of work, and unfortunately, to some degree, also manual work. So I'm going to leave you with this. SIS benchmark compliance with RKE2 and SUSE Security is not there out of the box, but it's definitely possible if you consider the benchmark to be the Kubernetes SIS benchmark and not each benchmark on the whole stack, on all layers of the whole stack. Thanks for listening to this talk. This is a SUSECon 2025 talk. My name is Daniel Druck. Have a great day.